Hello students, let's continue solving exercise 11.4 in this video. Fourth problem, second subdivision. 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta equal to dash. So options is given. So let's see. So 1 plus tan theta plus secant theta. So that we can write like this. 1 plus sin theta by cos theta. So tan can be written as sin theta by cos theta. And secant theta can be written as 1 by cos theta. Okay, similarly cot theta. Okay, here you have cot theta, no? So that cot theta can be written as cos theta divided by sin theta. Then cosecant theta is 1 by sin. Okay, now we have to take the LCM. So here in both the denominator you have cos. Only here you should multiply cos theta to the numerator. So cos theta plus sin theta plus 1. Okay, already you are having cos here, so you need not multiply anything here. So only here you should multiply. Then here in both the denominator you have sin and here 1. So LCM will be sin theta and sin theta should be multiplied only in the first numerator. So sin theta plus cos theta minus 1 you will get here. Okay, now both are in multiplication. Okay, so here it is multiplication only. So you can combine together. So what we are taking, cos theta plus sin theta as one term we are taking. Okay, here also sin theta plus cos theta. Here since it is in plus, you can change the place also, no problem. So cos theta plus sin theta and cos theta plus sin theta on both sides. So and here you have plus 1 and minus 1. So this is of the form a plus b into a minus b. That identity. Okay. That is equal to a square minus b square. So what is a here? Cos theta plus sin theta. And b is 1. Okay. So cos theta plus sin theta the whole square minus 1 square. Okay. Then we cos theta plus sin theta the whole square, no? So that is expanded with the algebraic identity a plus b the whole square equal to a square plus b square plus 2ab. So a is cos theta, b is sin theta. So you can write like this. Okay. Now if you see here cos theta plus sin theta, what is cos theta plus sin theta in the trigonometric identity? It is equal to 1. So you will get 1 here. Okay. And you have one more minus 1 here. So 1 and minus 1 that will get cancelled. Here you have 1, here you have minus 1. So that will become 0 and you will be left with 2 cos theta sin theta divided by cos theta sin theta. So cancel cos theta, cancel sin theta. So you will get 2 alone as answer. So the correct option is option C, that is 2. The next problem, secant a plus tan a into 1 minus sin a equal to dash. So let's see. So this is the given problem. So everything in terms of sin and cos we are writing. So see what is secant a? It is 1 by cos a. What is tan a? It is sin by cos a. Okay. Then this sin we can leave it as such. Sin a is already there, no? So leave it as such. Okay. Then next is we have to take the LCM. So here if you see both are cos a. Okay. So you need not do anything. Put together. Okay. So LCM is cos a. So write the numerator together. 1 plus sin a. And here this is multiplication. You need not take LCM for this side. Why? Because it is in the multiplication. So no need to take LCM. So write it as such in the multiplication. So since it is in multiplication, you can combine now. So for combining, what will happen? 1 plus sin a, 1 minus sin a. So in the previous problem, how we did? A plus b into a minus b equal to a square minus b square. Same algebraic identity. Here also we are going to use it. So we will get 1 square minus sin a square. Okay. So 1 minus sin square a. So what the trigonometric identity says? 1 minus sin square a is equal to cos square a. Okay. And in the denominator we have cos a. So here on top you have square, and here 1 cos A you have. So cos A and 1 cos A will get cancelled. So you will be left with cos A alone. Okay, since in the numerator you have square. Square means what? Cos A into cos A. Correct? Then in the denominator you have 1 cos A. So 1 cos A and 1 cos A will get cancelled, and 1 cos A will be remaining. Okay, so that's option C. Sorry, option D. Okay. Now next problem. Fourth one. 1 plus tan square A divided by 1 plus cot square A equal to. So let's see in the problem. So we can write 1 plus tan square A by the trigonometric identity. It is secant square A. Then 1 plus cot square A is cosecant square A. By the trigonometric identity itself we can write here. Then what is secant A? It is 1 by cos A, no? So it can be written as 1 by cos square A and 1 by sin square A. Okay. Now take this reciprocal to the multiplication. Okay. So 1 by cos square A into sin square A by 1. Okay. So this can be written as sin square A by cos square A. What is sin by cos? It is tan. Okay. So the final answer we will get, it is tan square A. So that is option D is correct. The next problem, prove the following identities where the angles involved are acute angles for which the expressions are defined. So we have to prove this now. So cosecant theta minus cot theta the whole square is equal to 1 minus cos theta divided by 1 plus cos theta. So we should prove this identity now. So we have this one. So next we will take LHS now. So LHS alone we are taking, and what is cosecant theta and cot theta? It is 1 by sin and 1 by cos by sin theta. Okay. So you may wonder how to start with. So if you see here, in the LHS we are having cosecant and cot, and in the RHS we are having cos. So you take that as your clue. So how to start with? So you can take this in terms of sin or cos, so that the final answer you may get like this. Okay. So that's why in the LHS I am doing like this. So I am taking cosecant as 1 by sin and cot as cos by sin. Okay. And the whole square is already given, so I am also writing whole square. Now next step, take the LCM. Both are having sin theta. So take sin theta as LCM and write the numerator as such, that is 1 minus cos theta. Okay. Now this whole square means what? For the numerator square and denominator square is there. So in the denominator I will get only sin square theta. In the numerator 1 minus cos theta. Okay. So by the identity, I can write sin square theta equal to 1 minus cos square theta. Okay. So that's one of the identities. So sin square theta is equal to 1 minus cos square theta. So since I want both numerator and denominator, I want in terms of cos. So that's why instead of sin, I want to bring cos. So how to bring it? So I'm using the trigonometric identity and bringing it. Okay. Now we have to simplify still more. So this, how to write it? This is of the form a square minus b square. Okay. So what is a square minus b square? It is a plus b into a minus b. Okay. So that's why I am writing a plus b and a minus b. So 1 minus cos theta, 1 plus cos theta. Okay. So and this is in square, that is 1 minus cos theta into 1 minus cos theta. Okay. Either you can expand it in the form of a plus a minus b the whole square formula. But here we don't need it. Why? Because here itself we have 1 minus cos theta. We have to think how to cancel it and simplify it. You need not expand in the form of a minus b the whole square formula. Okay. So here I have 1 minus cos theta and here 1 minus cos theta square. So write it for 2 times. So 1 minus cos theta. So 1 one a minus cos theta will get cancelled, and here this will cancel. So I'll be left with 1 minus cos theta divided by 1 plus cos theta. Okay, I have shown you how I have cancelled. So this square is get cancelled, and here this is get cancelled. So I'll be left with 1 minus cos theta divided by 1 plus cos theta. So that is the RHS. So LHS is equal to RHS. So hence it is proved. Now coming to the second subdivision, cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A equal to 2 secant A. Okay. So we have here sin and cos here, and we have secant here. Okay, so we can start with this itself. So let's take first LCM. So it is LCM is taken in the LHS, and it is written like this. And so in here for this numerator it should be multiplied with cos. Okay, so since you don't have cos here in this denominator, you should multiply this numerator with cos A. So this will become cos square A. Okay, then this is multiplied for 2 times. So 1 plus sin A into 1 plus sin A. Okay, so that means 1 plus sin A the whole square. So it is expanded with the algebraic identity A plus B the whole square formula. So A is 1, B is sin. Okay, so sin square A plus 1 plus 2AB, that is 2 into 1 into sin A. Okay. So that's why I am getting this one. Now if you see cos square A plus sin square A, so that is 1 you will get. So 1 plus 1 you will get 2. Okay, this is one identity. So I have shown you how the identity is taken. So you will get 1 here. So 1 plus 1 is 2. Okay, so 2 plus 2 sin A and divided by cos, just it's written in the front. That's it. So next step, I'm taking this 2 out common. So both are having 2. So I'm taking out 2 common outside. So I'll be left with 1 plus sin A. Okay. And in the denominator also you have 1 plus sin A. So both can be cancelled. 1 plus sin A, 1 plus sin A will get cancelled. So I'll get 1 by cos A. Okay. 2 into 1 by cos A. So what is 1 by cos? It is secant. Okay, so 2 secant A, that is RHS, hence it is proved. Then next one, tan theta by 1 minus cot theta plus cot theta divided by 1 minus tan theta equal to 1 plus secant theta cosecant theta. So we'll start with this. So in LHS, so LHS in terms of sin and cos we are writing, because here we are having secant and cosecant. So if you do with sin and cos, you can find it, you can make it like secant and cosecant. So write expanded with that. Then here LCM is taken. Okay, so LCM is taken. So I'll get sin theta minus cos theta divided by sin theta, and here cos theta minus sin theta divided by cos theta I will get. Okay, so this can be. Then the reciprocal is taken to the top by multiplication. That's why I am getting sin theta into sin theta, and similarly this side also cos theta into cos theta I am getting. So next step I can write it as sin square theta and cos square theta. And what I have done, sin theta minus cos theta is here, but here cos theta minus sin theta is here. So in order to bring it like this, I am going to take minus 1 outside. So I am getting minus here. Okay. So next step. So this I am getting as sin square theta minus cos cube, sin cube theta minus cos cube theta. So like this you will get. So by the a cube minus b cube, that identity. So like that it is expanded. So a minus b into a square plus b square plus 2ab. So like that it is expanded now. Then so sin theta minus cos theta is both in numerator and denominator can get cancelled. So it will be left like this. So sin square theta plus cos square theta, by the identity you can write it as 1. Then this is taken separately. That is cos theta sin theta is taken separately and it is written like this. What is 1 by cos theta? It is secant theta. 1 by sin theta is cosecant theta. So 1 plus cosecant theta, that is RH.